Hello everybody, I'm back again, and today I'm going to make a video showing you how to use the TI-84 calculator, particularly if you're in the IB course. If you're doing the AA or the AI course, I hope this video is going to be beneficial for you. So what I did was to compile some of the common questions that I usually see in the AI and the AA courses. And so some of the questions may be more exclusive for the AI students, while some of the questions may be exclusive to both AI and the AA. So I hope this video is going to be beneficial for you. For those who are using the Inspire calculator, I'll hope to make another video sometime in the near future. But because this is a request to use the TI-84, so I'm going to show you how the TI-84 calculator could be used to the fullest potential, so that you could use that efficiently, I would say, is particularly for the AI students, where you could use it for both paper 1 and 2. AA students, you can only use it for paper 2. So hope this video is going to help. I'm going to try to keep the video as short as possible, so I'm not actually going to show you like how to write your workings in an exam or in a test, because this video is specifically about how to use the calculator. So please do follow the video. I will caption this. I will put on timestamps as well. You should be able to see those timestamps so that you could find the questions that you think is probably something that will be beneficial for you. But otherwise, I think it would be helpful for you to watch the video from the start to the end. And alright, so let's get down to business. Alright, so I'm going to start off with financial maths first, which is about compound interest, and there was a bonus question that you could see on the screen, which is about depreciation. This is definitely exclusive for both the AA and the AI classes as well. So I'm going to quickly show you how I could use the calculator for this question. So I'm going to look at the first question about compound interest. It's about a monthly, the interest is being compounded monthly. So you invest $8,000, annual interest rate 3.75, compounded monthly. How much will your investment be worth after 6 years? Okay, so we're gonna go straight to using the calculator. We're gonna go to apps. We're gonna go to finance, and we're gonna click on option 1. For the AA students, I know you could use the formula. Absolutely fine. Please go ahead and use the formula if you've been taught that way. But again, this video is exclusive for just simply using the calculator. I just want to show you an alternative way. If your teachers have not taught you this, this could be another way that could be a lifesaver for you if the formula has always been a source of trouble for you. And all you really need to do is just to put down what you see on the calculator as part of your workings as well. Alright, so we're going to look at this. It says that you're going to invest $8,000 with the interest rate and after 6 years. Now, N on the calculator generally means the number of repayment periods. Okay, now since your interest rate is compounded monthly, but it did not basically say how much the interest is going to be given to you, right, in the question. So of course you could choose N to be based on the number of years, or you could be based on the number of months. Alright, I'm just going to do it all in terms of months, just because it says that the interest rate is compounded monthly. So basically, if the interest rate is compounded monthly, in a year it's going to be compounded 12 times, right? So in 6 years you're going to have 12 times 6. So if I do like 12 times 6 here, I'm going to get 72. Okay, I just leave the calculator. I'll just leave it as 12 times 6. I think that generally be fine. Then what I'll do is if I press enter, it obviously gives me 72. The interest rate is 3.75, so I'm just going to type in 3.75. PV, which is the present value, is basically how much you invested in this particular scenario here. So since you're investing $8,000, means that there is a cash outflow since you're investing money into perhaps an investment or something like that. So I'm going to make this to be negative 8,000, okay, because if you're investing money, it means that money is coming out from you. Okay, so it's negative 8,000. PMT, which is basically your it could be the payments per period. It could be based on a monthly period, yearly period, but it depends on what the question is. But in this case, there is no payment, so we will leave that as 0. Future value, I'm just going to keep that at 0 because that's really what I want to find eventually, but we will find out what that value is. Now PY is basically the number of payments per year. Alright, so in this case we have obviously assumed that the interest will be paid to you on a monthly basis. So in this case, since we're looking at in a year, then we have to do 12 times, isn't it? Because since we are assuming that it's being paid to you on a monthly basis, that's why PY and N, they are interconnected. If N is based on the number of years, then PY would just be simply 1. Okay, then N would just be 6. And technically both will give you the same answer. And finally CY, which means the number of compounding per year. So we know that the interest is being compounded monthly, so CY has to be 12. Okay, because you're going to have 12 compounded interest in a year. So in this case, then we're just going to go up to FV, then we press alpha, we press enter. All right, and it should give you $10,015 and 6 cents. Okay, now I just want to show you what happens if I change my N to be 6. Now if I change N to be 6 and I change PY to be 1, okay, just based on the number of years, I'm going to go up to FV again. I press alpha, I press enter. We'll try it again. Alpha. This should be 12. For some reason, the number has changed. So I'm going to go up to FV again. So I press alpha, enter. Now I should get the same answer again, which is $10,015 and 6 cents. Okay, so just remember, to summarize this, N and PY, they are interconnected. If N is based on the number of years, then you have to consider PY to just simply be 1. But if N is basically considered as the number of months, then make sure you change PY to be 12. Okay, all right, so I would like to show you as well that this question could be done with a depreciation question. All right, so it says that the brand new car was bought at 200,000, depreciate a rate of 20% each year. What's the value of the car after 10 years? Okay, now generally we could also use the calculator. You could use the formula as well, but in the formula booklet, it doesn't indicate the formula for depreciation, but really all you need to do is to change the addition to a subtraction sign. And that's where the formula can be used very effectively. But I just want to show you, like, you could easily use the calculator to get the answer as well. Now, if I'm going to say after 10 years, that N is going to be 10. All right, we talk about the depreciation rate to be 20%. Now, in this case, we don't just simply put 20, we put negative 20. Because the value is going to be dropping in terms of the value of the car. So if you put I to be a negative number, you're telling the calculator that you are expecting the future value to be lower than the present value. Okay, so the present value, I'm just going to put 200,000 because that's the price of the car. And PY and CY, I'll just leave that as 1 by default. And FV, which is the future value, which is basically the value of the car after 10 years. Then I'll just press alpha, enter, and there we go. You're going to get $21,474. Okay, there is a negative sign on the calculator because PV and FV generally they have alternate signs. Okay, but when you write the answer to this question, you could just simply ignore the negative sign. So you could just leave the answer as $21,474.84. Okay, or you could round your value to 3 significant figures. Okay, all right, so hopefully this sorts out how to use compound interest with the calculator, which I think is absolutely efficient to use the calculator rather than just simply using the formula. You just simply need to know what each of these terms actually mean, and the calculator will do the job for you. Okay, all right, let's move on to the second question, which is about annuities, which is regular savings or investment. This is primarily for just AI students. So AA students, you could obviously just skip this part and perhaps move on to question 4, which I will come to that shortly. Now, so for the AI students, you guys obviously would have done something what we call annuities. So let's just quickly get down to this question. You deposit $200 at the end of each month into an account paying, which gives you like 4.2% interest, and which is compounded monthly. So the question again is, what is the value of your investment after 15 years? Okay. So back to the calculator, and what we could do is we're gonna end up changing the numbers again. So N, again, this account is going to give you 4.2 interest compounded monthly, okay? And you will deposit $200 at the end of each month, okay? So what I'll do again is it's just a rule of thumb that I like to change N in terms of month based on the compounded monthly. So what I could do is I could change my N into months first, and since we're looking at 15 years, I could take like 15 times 12. You could have also done it in years if you want to, okay? I'll just show it to you. So I, in this case, will be 4.2, which is the interest. PV, which is the money that you... Now, the thing is, you do not have a present value in this case, because what this does is that at the end of each month, you're going to start putting money into that little investment. So in this case, your PV, all right, should be 0, because you're only putting $200 at the end of every month. So which means that leads us to PMT, which is the payments per period. Now the period will be at the end of each month, and since you're depositing $200, then this should be negative 200, because again, there is a cash outflow and money is going into your investment account. Okay, so FV, this is what we want to find. I'll come to that later. PY in this case would just simply be payments per year. All right, and since you're doing it at the end of each month, so this has to be 12. All right, because you are doing it at the end of each month, and in a year you're gonna do it 12 times. All right, and finally, because the compounding is compounded monthly, so you're gonna have CY to be 12, because in every year you're gonna have 12 times of the compounding of the interest, so it'll be 12 as well. So if I go up to FV, all right, what I'll do again, I'll do alpha and I'll press enter. Okay, so in this case, you should get $50,031, all right, and 23 cents in this case, okay, which means that you're expecting this amount of money in your investment after 15 years. Okay, so again, to summarize this, PMT is basically payments per period, and your PY, which is the payments per year, will be 12, because you are actually getting you're actually depositing this account every month. All right, so you are basically paying 12 times a year as well. Okay, just remember, there has been some misconceptions that PY and CY always have to be the same value, and that's not true at all. Okay, so please do read the question before you start plunging in the values onto your calculator. All right, let's move on to question 3. We're going to look at amortization, which is basically the repayment of a loan. That's usually the common thing that we see about amortization. So basically, it's all about you taking a loan and you want to repay something. Could be buying a house, buying a car. So generally works very much the same again with the calculator. So again, let's just try to put in the numbers onto the calculator. Okay. So we have 25,000 as the amount that you would like to borrow. Interest rate 6%, compounded monthly. You pay the loan monthly over 5 years. So this is important. You're paying the loan monthly over 5 years. So what is your monthly repayment amount? Sorry. So N, I would have to convert this into months again. All right, since you're paying the loan monthly. So, and we're talking about 5 years. Now we're going to take 12 times 5. That should give me 60. Interest rate should be 6. Present value. All right, since you're going to borrow $25,000, so you should have PV to be a positive number, because since you're borrowing money and you have that sum of money, that means there's a cash inflow. So PV should be a positive number. PMT, that's what really I want to find, because you're trying to find the monthly repayment amount. So I'll leave this as it is first. FV, this needs to be 0, because if you borrow $25, ultimately your final intention is to ensure that you pay off that loan in total. So which means that the final value of the loan should end up to be 0 if you're hoping to pay off the loan. Okay, PY would be 12 again, because you're paying the loan monthly, so the payments per year would be 12, and CY would be 12 as well. Again, this is all a coincidence because it's just the way the question is being made. If it's compounded quarterly, then CY would just simply be 4. Okay, so please do not assume that PY and CY will always be the same value. So what I'll do is I'm going to go up to PMT. I'm going to press alpha. I'll press enter. There we go. Okay, and it should give you a negative answer, which is really nice, which is $483.32. Okay, so that would be the amount that you will be paying each month. Okay, so there we go. That's your amortization question. All right, then we're going to move on to some algebra work. Again, this applies to both the AA and the AI classes. Solving system of linear equation with 3 variables. For both the AA and the AISL classes, again, you're not expected to do this algebraically. So I could show you how you could do this with the calculator. And if we go on to apps, you should see a feature that say Polysmith 2. But in this case, Polysmith 2 on your calculator may not be option 4. Again, this is just my calculator, the emulator that I'm using. So, but just choose Polysmith 2, okay, if you choose option 4. And since we're trying to solve like a simultaneous equation, we want to choose option 2, okay? And since we have 3 equations and 3 unknowns, then all you need to do is just do 3 equations here, and we choose 3 unknowns. The rest, you could leave it as it is. I think that's fine. Then what you want to go is to go on to next. So you can press graph for next, okay? Then you just simply put in the coefficients of the variables. So in this case, it would be 1 because x is just 1x. I'll put 1. Then the next one, if it's a plus, then this will be 2. Then I'll press enter. Then since it's minus, I'll just choose minus. Then I would choose this to be 1 z. And finally, this would be 4. And we do the same thing for the rest of the equation. Okay, so I'm just going to quickly put in the numbers here. Try to follow me on this. This is minus. Then this will be 1. And this will be 2. And this will be 7. And finally, for the last equation, will be 2, 1, 3. Okay, let's do this really quickly. This will be 3. And finally, this will be 10. Okay. All right, and now you want the calculator to find the values of x, y, and z. I'm going to click solve, and you're going to get the 3 numbers here, which is 39 over 20, y equal to 7 over 4, and z to be 29 over 20. Okay, so that's really the answer for that. Now, if you want it in decimals, you can just click on this, which is FD. Then that will give you all the numbers in decimals, but it's not a requirement at all unless the question suggests so. Okay. So question 5, let's move on. All right, let's go really quick. It's polynomial equations. Again, at the AA or the AI level, technically you should be knowing how to solve polynomial equations up to the degree of 2, which means that quadratic equations should be the ones that you should be able to solve it by hand. But if you end up having to solve a cubic equation or anything higher than the degree of 3, then you should be using the calculator to help you to solve the equation. And we do the same thing again. We're going to go to apps again. So I'll quit this thing. So I'll just show you back to where it should be. Let's go to apps again. You choose Polysmith 2. I'm going to choose polynomial root finder. So I'll choose option 1. And since the highest power is 3, I'm going to choose order to be 3 as well. Okay. The rest you could leave it as it is. I'll click next. And all you need to do is just put in the coefficients of the variables in this equation. Okay, so it's 1. So it's really, really straightforward. Okay, there's really nothing that so this is minus. I'll press enter, then I'll press 6, I'll press enter, then I'll press enter, 3, press enter, then plus 10, then I'll press enter. Then I'll solve it, and there we go. You should have three unique answers for x, which is 5, 2, and -1. And there we go. That gives you the answer for this polynomial equation. Alright, so please make sure you use the polysmith feature well if you need to solve complex equations or solving simultaneous equation. This is a great tool to be using on the TI-84. Okay, and let's move on to question 6. Oh, this is another one that needs to be addressed, okay, which is solving complex equations. Again, for AA students, you will not be surprised to see very complex equations where you're supposed to find the value of the variable in the equation. So that's where you need to know how to use the calculator, right? And even for the AI students, again, same thing. If you end up having to solve complex equations, which you will see very frequently, this is where I want to talk about how we can solve this equation using both the numeric solver and the graph intersection, because there are pros and cons for both of these methods. But I want to show you why, and I want to show you clearly the limitations for both of these features that can be found on the TI-84 calculator. All right, so I'll show you the first way. The most popular way for this is basically using the numeric solver. Okay, but there is a limitation to the numeric solver, because I'll just show it to you first. I'll go to math. I'll choose right at the bottom. You should see numeric solver. I'll press enter, and all you really need to do is just put in the equation, which is super straightforward, right? I mean, x squared, then this would be 2 to the power of x. So it's perfect here. Now I'm going to click OK. Now, what the calculator needs you to do is to predict a value for x before it will come down, before it gives you the actual value of the x. So if you make the prediction correctly, that's great. But if you don't, then it creates a set of problems. Okay, so what I'll do is I'll just choose a random positive number first. The way I like to do about numeric solver is I am always concerned about the fact that what if there is more than one solution for x. Alright, so I like to do it with positive first, and I like to do it with negative. So I'm just going to put a random number. There is no trick to this. It's basically just predicting what x possibly could be. Or you could even guess that x to be 2, because since there are a lot of 2's in this equation, so I'm just going to choose x to be 2 as my answer first, okay? Now I'm going to click on solve. Now, it seems like my x is supposedly will give me 2. So, well, I just make the prediction correctly. But if I choose x to be 5, okay? Alright, and I do not know exactly what the answer is, because initially I make the prediction of 2 and it ends up to be the value of 2. So I just got it really lucky to get the answer. But if x to be 5 and I click solve again, okay? Now, it's going to give me another value, which is x to be 4. Alright, so which means that when x is 5, what the calculator does is that it will find the answer which is really close to the prediction that I'm making in a way. So I just realized that there are two answers, which means that x could be 2, x could be 4, which means that you probably would have to use numeric solvers several times to find different solutions. You see where I'm coming from? So it can be quite annoying. And the thing is on the fact that if I'm going to do, let's say, I'm going to choose, let's say, a negative answer, let's say -4, okay? Then I'm going to get it to solve it. It will tell me that there is another answer, which is -0.766, which is also an answer to this solution, which means that there are just so many possible answers to this question. So that's where numeric solver can be extremely annoying at times, because it doesn't tell you exactly how many answers of x you could get. You have to go, you have to predict, you have to try several values of x in order for you to get a full range of answers for this equation. So that's where I think the limitation is there. But if you know that there's simply only one answer for numeric solver, I mean for the equation, then I think numeric solver is perfect. Alright, if you know that there is a unique solution to it. But if you know that there are multiple solutions, I really don't think this will be the greatest way to do it. So I think another way to do this is I'm actually going to put this into a graph. Alright, so what I'll do is I'll click on stat plot. I'm going to be prompted to put in the equation here, so I'm going to do x squared, and I'm going to choose the second graph to be 2 to the power of x. Okay, then what I'll do is I'm going to graph it, and you may have to take a while to wait for the graph. to appear. So I got two curves here. Okay, now but it doesn't really show all my intersection point, because it seems like as x gets bigger, there seems to be more intersection points at the top. So maybe what I could do is I could change my window size. Maybe I should change my x maximum. I'll probably just make it a bit bigger. I'll make my y maximum to be a bit bigger as well. Let's say if I do 30 as well. Again, no hard and fast rule. It's just based on the observations I see from my graph. I'm going to graph it again. I may have to change the window size again. Alright, you could zoom in. I think that's fine. Alright, but I think generally I could see several intersection points within here. And what I'm going to do is I'm going to get the calculator. So let me just try to see if I can get a better size to this. Probably not the best feature in this case. Okay, zoom fit is probably not to be good. I'm just going to choose back to standard. Okay, maybe I'll just change the window size just back to what I did. Again, no hard and fast rule here, but okay, I'm gonna graph it. 50 should be good enough. Okay, lots of intersection point. I'm probably gonna zoom in a bit. Let's do, okay. So what I'll probably do is I'm just trying to zoom in a bit here. Let's go. Okay, I just want to show you a few intersection points here, okay? That at the same time, we can try to find maybe the intersection points for this one. Okay, so there's a few intersection points here, right? So what I'll do is I'll go to second trace. What I'll choose is choose option 5. All right. Then it's always going to ask you for the first curve. So you want, now we know that there's probably an intersection point here. So what I'll do is I'll try to get really close to this intersection point. A little to the left of a little to the bottom of the intersection point. I'll press enter. Then I'll move slightly above the intersection point here. So what you're trying to do with the calculator is, with the first and the second curve, is that you're telling the calculator what are the two boundaries of the intersection point that you're trying to find here. Okay, so if I press enter and the calculator will prompt you to guess, there is no need to guess, just press enter again. All right, it will tell you that this is the closest intersection point of the boundaries that you just set here, which gives me x to be 4. And you could do the same thing if you were to go down and you want to find the next intersection point. Then you should be able to do the same thing again. So I'll just show you one more. I'll just go back to standard again, because there's one intersection point on the negative part. So I just want to show you like how we can find the intersection point. So there is another intersection point here. So what I'll do is I'll go to second trace. Okay, I'll just wait for it to load first. So second trace, then we go to intersect. So I'll choose a point to the left of the intersection point that I'm trying to find. I'm going to try to find this intersection point, which is the negative value. I'll press enter. Then I will go somewhere to the right of the intersection point. Press enter. They will ask you to guess. And you see, now it zooms in onto that intersection point that I was trying to find, which was negative 0.766665, right? Which was the same value that you got from the numeric solver. Now, what does that basically tells me is that you probably would have to do this like 3 times to find the intersection points. But this is a great way. I feel like this is perfect because you know from the graph that you have 3 intersection points here, which means that you know that there are 3 different solutions to this question. Like visually, you can actually see it. So that's why I think this is a great way if you are solving complex equations. and where you know that there's a very high chance that you'll be getting multiple solutions. Okay, so that's why I hope that you are able to see these two different ways, and hopefully you just got to find the appropriate way when you see the equation, and intuitively, if you know there's only one solution, or if the question suggests that there's only one solution, then use the numeric solver. Otherwise, please use the graph intersection. I think that's probably a preferred way to solve a complex equation. Okay, all right, hopefully this helps, and we're going to move on to the next question. We're going to look at domain and range, another common questions that we see on functions. So I think this well, for this question, I think the AA students would probably need to know how to do it without the GDC. But again, this is primarily a GDC video, so I just want to show you like how we can actually find the domain and range for this question. Okay, so if you have a question like this and you are asked to find the domain and range, then really what you need to do is just graph it. Yeah, so you want to graph this equation. So I'm going to clear these two equations that I just put in earlier. So I'll go to second, I'll click on this, get the square root sign, so this will be 6 minus x, then this will be plus 2, and I will graph it. Let's see how the graph looks like. Now, it seems like the graph stops at this little point here, but it seems like it's going infinitely in this direction. It goes like higher and higher and higher, isn't it? So we could easily say that if you look at the domain is basically what are the possible x values that could be seen in this graph, right? So we know that at this point here, if you count the number of lines, which is 1, 2, 3, 4, 5, 6, it seems like x stops when x is 6. Okay, now if you want to be sure, all right, that this is actually the lowest point, I can just quickly show you by using a table here. All right, and if we go down to 6, there is a value where when x is 6, y is basically 2. But after 6, you realize that it gives me an error because the graph, remember, it only stops when x is equal to 6. And it kind of makes sense as well, because if you put any number which is greater than 6 in x, it's going to give you a negative number under the square root sign. And you can't square root a negative number when it comes to real number terms. So that's why it makes sense that the highest value of the highest value of x will be 6. Now, if I go back to second table, you realize that anything that's bigger than 6, there's absolutely no way you're going to get an answer. Okay, but if you scroll up and you find values which is getting smaller for x, you realize that y is getting bigger. So which means it's going infinitely upwards in the negative portion of the graph. Okay, so then what does this basically mean if you want to write the domain? All right, so of course, if you know that the highest value is 6, then what you could really do is, let me just see if the pen here works. All right, so we can say that the domain is just simply x, which is smaller or equal to 6. So that's going to be the domain of this graph. You need to write this, okay? You can't just see. I will still suggest, or if you want to write it in words, that x is always less than or equal to 6, I think that's fine in general, but I think if you know how to write this in notations or inequality signs, please make sure you do so, okay? Now, then it asks for what is the range, okay? Now, if you look at the range, I'm just going to go back to the graph, all right? Now, it's quite obvious that at this point, there is a y value here, all right? The y value at this point would be 2, all right? Just by looking at the graph, we know that the lowest point for y is going to be 2, and it's going to go infinitely upwards, so which means that y has to be greater or equal to 2. But if you look back at the table again, all right, again, just to be sure that we are on the right track, you see, if I go to 6, you realize that this value, the smallest value of y, is basically 2, and any value beyond 2 is when x gets smaller, so that means y's smallest value is going to be 2, and there is no limit to the highest y value. So in this case, when we write the domain, we can just simply put for the range would just be y would be greater or equal to 2. Okay, and that will give me the range. All right, so the calculator can be extremely useful because you could basically visualize the graph, and you should be able to write the domain and range by using inequalities as well. Okay, all right, so hopefully this helps for domain and range. Let's move on to the next question. Okay, let me just get the pen out of the way for now. Let's see, I don't want the pen anymore. What do I do with this? just click this. Yep, that should clear up. And I'm just going to use the eraser. Let's erase this. There must be a better way to do this. Let's clear all. Perfect. Okay. Now what we're going to do is we're going to sketch and identify key features of this graph. So again, if you're going to get some strange looking function like this, which is x minus 9 over x plus 2, and you are asked to identify some of the key features here. So what we want to do is to use the calculator to help us with this, to identify some of the key features here. Now again, with the AA course, you should be able to identify how to find a horizontal asymptote and a vertical asymptote without the use of the calculator. Okay, this is something that needs to be done in this course. So if you have no idea how to find asymptotes, please maybe drop me a message in the comment box, and I could make a separate video on this when it comes to asymptotes. But I just want to show you really quickly how this can work on the calculator. All right, so I'm going to put this equation on the calculator. So I'll go to alpha link. That's going to give me the fraction symbol. Then I'm going to click on x minus 9. Then I have x plus 2. Then I'm going to graph it. I'm expecting a disconnected graph here. All right, still waiting for the graph to load. Now, it's pretty obvious that there's going to be a vertical asymptote and a horizontal asymptote because there is a disconnection between the two portions of the graph. And remember, what an asymptote does is that it's a line where the curve is going to get really close to the line, okay? But it's not, the graph is not going to touch the line, all right? So that's really what causes the disconnection here. And there's going to be a disconnection here as well. So that's what we call an asymptote, okay? Now, what we could do is that I'm going to find out some of the basic common things first. We're going to make sure that we find out what is the intercepts first, which is the x-intercept and the y-intercept. And let's, now, again, by looking at this graph, it is quite evident if I go to second table, all right? I'm just going to find a few things here. Now, you obviously see an error, which means that when x is -2, the graph is not going to touch the y-axis. That's why there is a value for when x is -2, there is no number for y. So that really causes that disconnection somewhere. Then again, if I scroll down, and there we go, you realize, right, there is actually a value for x that actually gives me y to be 0. That means this number is actually the x-intercept, which is 9. Okay, but having said this, all right, using the table could be one way to find all the x-intercepts. If I scroll up again, okay, the number seems to get bigger. Okay, so obviously there is no x-intercept here in this case. But back to the graph again. Now, if you really want to find the x-intercept because you're clearly convinced that it touches the x-axis, then we can go to second trace. What we could do is we can click on 0. Okay. Then I'm going to go to the left bound. So the left bound basically is you want to set the boundaries where you know the x-intercepts lie in on the graph. So if I press enter and I scroll to the right here, so we know the x-intercepts will lie somewhere about here. So I'm just going to go a bit more to the right. Okay, I'll just press enter again. Then I'll get them to guess. Okay, now if you see quit, it means that you are not setting the boundaries correctly to get the x-intercept. So maybe what I need to do is to go back to the, I'll quit again. I may have to graph it again. All right, because the x-intercept could be somewhere here, but it doesn't look very close. But maybe I should zoom in this case, okay? I should zoom in about, let's say, somewhere here. So I can see where the graph obviously touches the x-axis. So it's going to be somewhere about here. All right, so I'll do the same thing again. I'll go to second trace. I'll go to 0. 0 means you're trying to find where the x-intercept is, or the roots. So somewhere to the left, I'm going to click here, and I probably should go somewhere to the right, which looks somewhere about here. Press enter again, and there we go. And you found x to be 9. That's the x-intercept here. Okay, so that is actually going to be the 0. 0 basically means the x-intercept, or you could be called as the root as well. So root, zeros, x-intercept, they all mean the same thing. Okay, now so again, I'm going to just get my back to my usual graph. I always go to option 6 if I want it to be the standard size, but you could zoom in basically based on your needs as well. Okay, since we're trying to find the x-intercept, then I had to zoom in because it wasn't very clear if I were to use this little size here. Now what I need to do next is, if I want to find the y-intercept, like where the graph cuts the y-intercept, of course you could count, okay? But if you want to save the trouble, you can actually go to second trace. Then you could choose something what we call value. All right, press enter. And what you need to do is just choose x to be 0, because this is where you get to see your y-intercept. So I press enter. Then you should get to see your y-intercept here, which is -9/2. Okay, so that's going to be your y-intercept. So that's how you find your x-intercept, your y-intercept, which is, and now if you want to find your horizontal asymptote and the vertical asymptote. Now we know the vertical asymptote is a line that cuts like this, like a vertical line that cuts like that. Okay, let me see if I can use my pen here. Let me see if it works actually here. Nah, it doesn't work on this. It has to be on the screen. But you could see if I draw a vertical line like this, okay, this is actually what we call a vertical asymptote, because this is the line where if you draw it, the two parts of the graph is not going to touch that line, but that's what it causes a disconnection to the graph. And there is also what we call a horizontal asymptote, which is like a horizontal line like this. It's causing that disconnection as well. So then you might ask, then how do I find the vertical asymptote or the horizontal asymptote? It's actually quite easy. We can actually go to table. We go to second table. If I want to find, we're going to find the x value first. That actually gives me an error. That's going to give you the vertical asymptote. Now you realize that at -2, it gives me an error. So this line, so I'm going to put it here. So I can simply just write x to be -2. This is actually what we call the vertical, oops, what's wrong? Okay, let me try this again. I think something is lagging here. Okay, try pen, -2. So this is actually the vertical asymptote, just to really quickly show you. So if you have a graph, something like this, you got a graph that goes like that, a graph that goes like this. X equal to -2 means there is a imaginary vertical line here. This is actually what we call a vertical asymptote, which is at -2. This is actually what causes the disconnection between this the graph. Okay, so this is actually what we call a vertical asymptote. Now to find the horizontal asymptote, which is basically the horizontal line, then we want to find out which of the y value, all right, is actually giving me a disconnection. All right, so I need to scroll down and see what is my y value. That gives me another problem here. Okay, so let's see. I'm expecting the y, it should be a negative value. So you realize that when x gets bigger, you should get like a number here, which makes perfect sense in a way. Okay. Let me just try to make this a bit smaller. Just trying to fit into the graph here. Okay, so we're going to be on the hunt to find out now. To find the horizontal asymptote is not really that clear cut from the calculator. Okay, because ultimately what you're trying to do is you need to identify what is the y value that is actually missing from the table of values. Now it's easy to find the vertical asymptote by looking at the value of -2, which gives me an error. So that obviously gives me the vertical asymptote. But the horizontal asymptote would not be very clear cut from the calculator because it really doesn't tell me anything more just by looking at the table of values. Now, obviously for the AA students, you have obviously learned how to find the horizontal asymptote. For the AI students, you do not need to know how to find the horizontal asymptote at this point of time, but you just need to know what asymptotes basically mean from the calculator. But one way to do it, I think the fastest way from the calculator, is just simply look at which number does the curve not get close to. Okay, now we know that this graph is going to get really close to a certain number, but it seems like it's never going to touch one of the possible values in this case, which happens to be 1. So if I were to draw a graph here, okay, so let me just use a pen here. Oops, no, that's not what I want. Let me use a different color. So what the horizontal basically means is that if I have a horizontal line here, okay, there is a particular part. Wait, let me just graph it again. So there is this little horizontal line that needs to be drawn where this graph is always going to get close to it but never seems to be able to touch this particular line. Okay, and this number happens to be 1 in this case because of the fact that one easiest way, especially I think the AA students would know, is that if you look at the power for x, this would be 1, this would also be 1. So if we have these two powers to be similar in this case, what you need to do is just take the powers, which is 1 divided by 1. That would give me 1 as well. So which means simply that y equal to 1 is just going to be the horizontal asymptote in this case. Now, there is something that's not very obvious on the calculator, is that you need to identify from the calculator that the calculator is actually going to reach a certain number in this case as you get smaller with the graph. Okay, which is actually going to be 1, but it's just not very obvious because you look at this 5 over 16, 6 over 17, 7 over 18. If I keep scrolling up, alright, in order to get 1, you need the numerator to be the same as the denominator because that's where it gives me 1. So look at this. The more I increase my x, my fractions gets bigger, but it's never going to get to a certain number which is 1. And you realize that the numerator and the denominator will never be the same, but it just gets really close for these two numbers. Okay, so it's quite clear, but on the calculator it's just not very obvious on how you could find the horizontal asymptote. Okay, but like I said, the AA students would need to know how to find the horizontal asymptote by taking the highest power and you just divide them. So you're going to get to be to the power y equal to 1. But for the AI students, all you really need to do is just identify from the graph where the horizontal asymptote could be like. And in this case, it seems like the graph would never be able to touch y equal to 1. So that's why y equal to 1 would be the horizontal asymptote. Okay, again, not a very clear-cut process. But generally, for the AI students, as long as you're able to sketch the graph, you're able to find the intercepts, the zeros, I think generally you'll be on the very right track as well. Okay, and just have a rough understanding of how asymptotes basically work. All right, so let's move on to the next question. Let's clear everything here. Another question that's very popular is basically using the table of values. Okay, now the table of values are a very powerful feature when you get a question like this. So it says that a biologist is studying a population of bacteria in a laboratory culture. They give you the function of the bacteria, which is n, and at any time t hours of the observation start is modeled by this function, which is 20 times 3 to the power of 0.5 t. This is what we call an exponential function. The question is asking, find the number of complete hours it takes for the bacterial population to first exceed 10,000. Now, technically what this question is asking is basically, can you find t when this is bigger than 10,000? That's really what the question is essentially asking. Right? Can you find the value of t so that when you put the value of t into this equation here, it will exceed 10,000? And the question says find the number of complete hours, which means that we are expecting the answer to be in whole numbers. Okay, so, and I will show you that this can be done essentially within like a minute. Okay, so what I need to do is I'm going to graph this equation here. Okay, so let's click on this. Let's clear this. 20 times times 3 to the power of 0.5x. Okay, then I'm gonna graph it. No, I'm not gonna graph it. I'm gonna go to second and table. Now, what I need to do is I'm going to find the value when x is actually the first number of x where it gives me a number which is bigger than 10,000. Okay, so because obviously we used the table earlier, so I need to scroll back again, maybe back to a smaller value of x. Now look at the number, it's getting smaller. This is really what I'm looking for. Look at that. When x is 10, it's 4,860. When x is 11, it's 8,417.8. But when x is 12, it's 14,580. And that's really what the question is asking, right? What is the number of complete hours it takes for it to first exceed 10,000? So please use this feature here. It's excellent. So we know that when x is 12, it's going to give me 14,580. So the number of complete hours that it takes for it to first exceed 10,000 would be 12 years. 12 hours. That's it. So easy. Okay, so if you could use the calculator and you have to solve like an inequality, or if you need to find a certain specific number, use the table of values. Awesome. Now, but you could argue that this question could generally be a little tougher if it says find the number of hours it takes for the bacterial population to first exceed 10,000. Now, if you put 12 hours, that's probably not going to be the best answer. Okay, because 12 may not be the most exact answer. So that's where I would suggest where you should be drawing the intersection between this graph and 10,000 and find the intersection point. So if without the word complete, you will have to draw the two graphs and find the intersection point. But if it's just simply knowing that the answer is going to be a whole number, then please use the table of values. Okay, all right, and yeah, then let's move on to question 9. Let's clear all again. Oops, let's just deactivate the pen as well. All right, now we're going to go on to statistics, okay? And this should still apply very nicely to both the AA and the AI student. Again, a very popular question about finding the mean, the standard deviation, and the interquartile range. Again, if you have, this is just a context about the breakdown of the grades of IB exam, and you want to put this onto the calculator without, of course, you should be able to do this with the GDC, finding the mean, the standard deviation, and the interquartile range. But the AA students, please make sure you know how to do it without the calculator as well, okay? But again, it's a calculator video, so I just want to show you how to do this with the GDC. So back to the calculator. Let me get out this feature. What I want to do is actually I'm going to go to stat, okay? Okay, I'll try to make this a bit bigger. So I'll go to stat, I'll choose edit, I'll put L1 to be grades and L2 to be my frequency, okay? So this will be 1, 2, 3, 4, 5, 6, 7, okay? Then we're going to go on to the frequency. Now remember, frequency basically means how many students actually get this particular grade. All right, it's not another variable. I think that's where students get confused. They assume that frequency is another variable, but this is not a 2-variable statistic. This is only a 1-variable statistic because grade is the only variable that comes to this. Why we put frequency is because we don't want to write grade of 1 to appear 12 times because there are 12 students who got 1. If you actually put this in layman terms, it means that you need to write 1 12 times. But that's just way too many ones to write because we have other grades that appear quite frequently as well. So we don't want to write these numbers like repeatedly. There's just too much repetition. So we put it into the table and we call the number of students to be just simply the frequency in this case, okay? So you see the point here. Sorry, I need to change this. This should be 6, then this should be 7. Then we put the second column to be the second row numbers, 12, 8, 14, 7, 20, 12, 6. Okay, 7, 12, 20, and 6. Okay, oops, sorry, it should be, so it should be the other way around. This should be 20, and this should be 12. Okay, now then the next part, if you want to find the mean, standard deviation, and the interquartile range, what we need to do is to go back to stat. We go to calc, choose one variable stat. Remember, this is not two variable stat. We choose option 1. You press enter. Now, frequency list. If there is a frequency that we put in here, then you need to put this as L2. Okay, to get to L2, all you need to do is just press second and press 2, and that way you get L2 here. Then you press calculate. Then you press enter. Then it should give you all the numbers that you want. So the first one, which is x bar, which is the one with a little line on top of x, that's the mean, which is 3.95 if you round it to 3 significant figures. Standard deviation, we're going to be looking at this one, which is sigma x, which is 1.87. This is actually what we call the population standard deviation, and that's what is expected in the IB. Now, Sx is the sample standard deviation. That's not what we're looking at when it comes to the SL course, okay? So we're looking at 1.8684548 to be the standard deviation, and just make sure you round it to 3SF. Now, to find the interquartile range, your calculator doesn't give you the interquartile range directly, but what the calculator does is that it does tell you what is the interquartile range, which is Q01, and Q3 to be the upper quartile. So if you take 5 minus 2, because interquartile range is defined as the upper quartile, subtract the lower quartile. So I'm going to take 5 minus 2, that gives me 3. So that's going to be the interquartile range. So just take note, the calculator doesn't give you exactly the interquartile range answer, but you have the upper and the lower quartile, which still somehow make things pretty easy for you to find the IQR. Okay, alright, so let's move on to question 10, which is linear regression and PMCC, which is the Pearson moment correlation coefficient. Generally, what PMCC does is to find the correlation between two variables. So a very common question is they loved asking what is the best fit line equation or the regression line equation, and also to find whether the line, what is the correlation coefficient using PMCC, which basically tells us whether if there is a correlation between X and Y. And from a visual graphical perspective is to see if the points are clustered very closely to one another. Chances are is the correlation is usually quite high as well. Okay, so again, if you want to put all this onto the calculator, super easy. We go to stat, we go to edit, put all the numbers here. Let's just delete all the numbers right here. Then we're going to put in these new numbers here. Okay, so in this case, it'll be 1, 2, 3, 4, 5. So the first value, which is x, I'm going to put it in the first column. So it's 1, 2, 3, 4, 5. Again, these are all very unrealistic data, but in a typical IB question, they will give you some rather realistic data with a context as well, rather than just simply call it x and y. So I'll put 2, I'll put 4, I'll put 6, I'll put 8, and I'll put 11. Okay, and we're done. Then we're going to go to stat, we go to calc. Now, since we are trying to find, we're going to actually do part A and B all together at the same time. Okay, now what we want to do is we want to choose linear regression. Okay, because what linear regression basically does is that it's going to find us the best fit line equation. Now, if you want to do like a curve, you know that it's going to be a curve that that probably will fit the points better. Then you could choose other regression form like the quadratic regression, the cubic regression. Quadratic means that you're trying to find the best parabola that passes through the points. Cubic means that I'm trying to find the best cubic graph that passes through the points. So that's what regression basically does, okay? But since we're trying to find the best fit line, which means we know that this has to be a linear, we usually choose option 4 rather than option 8. Then we press enter. Again, x1 and x2, L1 and L2, that's correct because we put the data under L1 and L2. We typically don't need the frequency list, so we can actually clear this. All right, so I can just go to calculate, and it will give me the gradient, which is A, which is this line, which is 2.2, and B to be negative 0.4. And the R that you see here is basically the correlation coefficient, which is 0.9.